let's go over the answers to the questions from the little practice quiz. All right, so we have two pairs of corresponding sides known congruent. This side is congruent to itself. It's a shared side using the reflexive property. And that gives us three pairs of congruent corresponding sides. So we have side, side, side triangle congruence. On to the next one. And if you got that one wrong, as long as you understand where your mistake was, then it's okay. And if you don't, you should ask questions in class tomorrow. All right, let's take a look at this one. Oh, actually, I guess Monday, since this is Saturday. So again, we have this shared side congruent to itself using the reflexive property. Okay, so there's one pair of corresponding sides known congruent. We have a second pair of sides, corresponding sides known congruent, but we don't have a third pair of sides. So if you said side, 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 that would be wrong. How about side, angle, side? Now over here, we do have the included angle, okay? But this one over here is not the included angle. And if the angle that's known congruent is not the included angle, even if they were both not the included angle, we would not have congruence, because this is side, side, angle on this one. It doesn't even matter that the other one is side, angle, side. The other one is correct. All right, so if we had this over here, side, angle, side, then we would know the triangle is congruent using side, angle, side. But side, side, angle, not a congruence postulate, and therefore these triangles are not congruent. All right, that was a not congruent. Let's look at the next one. This one is actually kind of similar to the other one. All right, again, we have two pairs of corresponding sides known congruent, and as remarked, we do not have a third pair of corresponding sides. The angle, I'm going to actually just kind of highlight it. All right, so here are two sides, right? Two sides known congruent, and notice where the angle is. All right, it's between those two green sides I just marked. Right, that is the included angle. Right, so your angle has to be right in between. Right, it has to be made up of the two sides that are known congruent. That is the included angle. This, however, is not the included angle. See, look where our sides are. Right, the included angle is between the two green sides. This is not between. Right, that is not the included angle. Not the included angle. And you should have said not congruent. Right? If it's not the included angle, it's no good. Right? At least no good for side, angle, side. Let's take a look at the next one. All right, let's do a sort of a little proof here. And I'll just start writing green. All right, so we have our statements. And we have our reasons. You have to have a reason to make a statement. You can't just go saying things for no reason. All right, we can say that AB is congruent to DB. And that is given. Right? You can see that nice 12 on those two sides there. So we know those are congruent. 12 is same as 12. We can also say that angle ABC, and notice we do have to use all three letters here. We can't say angle B, because what angle B do we need? I don't know. There's two there. All right, so we have to use three letters to name the angle. Angle DBC. Okay, so ABC corresponds with DBC. Okay, and that is also given. You can see it's 45 degrees. Didn't take any guesswork there. I'm just going to move this down just a little bit, so that I have a little more space. There we go. All right. So, and we can also say that BC is congruent to, it would go as BC. Right? The B's go together. Right? You can see angle B as in ABC is congruent to angle B as in DBC. So it does go BC congruent to BC. We have it marked correctly. And that would be the reflexive property. And is that enough to prove the triangle is congruent? Why, yes it is. Triangle ABC is congruent to triangle DBC using side angle side triangle congruence. So if you said side angle side on this one, you were correct. That one is side angle side. And just to make sure everyone sees that that angle is the included angle, I'm just going to mark the sides there, okay? So, right, those are the two sides from triangle ABC. Notice the angle is right in between them, right? Right there. Right? It's made up of those two sides. And the shared side, and this side I just drew in, is the two congruent sides in the two sides that are congruent to sides in the other triangle for triangle DBC. And notice included angle. So those are the included angle on both. I'm going to put angles because they're both included. All right? That looks kind of messy though. So I'm just going to erase this part, but I will leave up the fact that these are the congruent parts. And I'm going to write this in red right here, just so you see those are the included angles. Okay? You should be able to do a simple proof like this. Right? You're looking to get 3 pieces from each triangle congruent to the corresponding pieces in the other triangle. And based on those pieces, that's what's going to tell you what kind of congruence postulate you have. You have to match one of the postulates. Right now you only know 2. So either you have to get all 3 corresponding sides congruent, which isn't possible in this one, or you have to get 2 sides and the included angle congruent and use side angle side. And we're going to learn some more. We're going to learn 3 more ways to prove triangles congruent in the upcoming lessons. Right? So you should be able to do a simple proof like this. Right? And if you didn't get the question right, when you did the little practice quiz, just ask me in class. I could review it. I mean, if you didn't get it right and now you understand, that's fine. But if you didn't get it right and you still don't understand, then you can ask me. All right, so this one was not a question on the practice quiz. We're just going to do this one together. All right, so what are the congruent parts in each triangle? Explain. All right, so we'll just do a little proof to explain here. Actually, you know what? Let's do a paragraph proof. We don't do enough paragraph proofs sometimes. All right, so I am going to say that Kn is congruent to, well, what's the other side with the 2 hash marks? Why, it's Mn is congruent to Mn, and Jn is congruent to, what's the side with only 1 congruence mark? Why, that's Ln. Oops. Ln. Because it is given, or you can say it is known, well, right? Because it's given, right? You could say Kn is known congruent to Mn and side Mn and side Jn, and side Mn, and Jn is known congruent to side Ln because it is given, right? We know that because it's given. All right. So how about what else do we know? We also know that angle 1 is congruent to angle 2. Hopefully you saw that those are vertical angles because they are vertical angles. They're vertical angles. 2 angles formed by intersecting lines, and they are the angles opposite one another. Oops. Now I'm saying what I'm writing what I'm saying instead of writing vertical angles. Right, because they are vertical angles. Therefore, what we're trying to do, show the triangles congruent. And we have to make sure we match them up correctly. Triangle J and K If I say J and K, I have to say triangle LNM using, well, we have side angle side triangle congruence postulate. Notice that angle 1 and angle 2 there, are the included angles. They're the angles that are in between each of the pairs of congruent sides using side angle side triangle congruence postulate. And there we are, a very simple paragraph proof. It really is no different than our two-column proof, except I have those connecting words to just take my statements and my reasons and make them sentences. All right, let's look at the next one. Also, this was not on the little practice quiz. Actually, we've gone over all the questions on the practice quiz. We're just going to go over some notes. And I've given away every set of my notes. So make sure you're kind of following along in your notes. I believe at least one of these slides, it might be in the next podcast, is in your notes. I don't believe this is the one. I believe it's upcoming in the next podcast, but just follow along with me and just be glancing at your notes, checking, and of course you can always write additional information. You have that one page that's all blank you can add stuff to from the page I gave you in class. In the diagram, ABCD is a rectangle. What can you conclude about triangle ABC and triangle CDA? All right, so there might be some things you don't know about rectangles, but maybe you do. Maybe you learned them in another class. Maybe your 8th grade class. Well, you should know that opposite sides of a rectangle are congruent. Right? I have it right there. Opposite sides of a rectangle are congruent. Therefore, AB is congruent to, I always want to make sure I match up the corresponding parts. A should go with C. You see that in the triangle congruence statement right up here? A should go with C. So it should be CD. I really should have, these are segments, so I should have the segment markings. And AD is congruent to CB. Angle B and angle D are both equal to 90 degrees. They're right angles, right? All the angles in a right triangle all the angles in a rectangle are right angles. The only angle in our triangle there that is a right angle is angle D and angle B, because angle A and angle C, this whole angle is a right angle, but that's been divided into two angles. A little piece for each triangle. Triangle ABC and triangle CDA are congruent by the, notice where that angle is located. That is the included angle. Right? That's the included angle right there. And if we look over here, that's also the included angle over here. It is between the two pairs of congruent sides. I'm going to move this over because it's looking a little busy in my rectangle there. So therefore, we can use side angle side. SAS triangle congruence postulate. Decide whether the congruent statement is true. Explain your reasoning. Okay? So we're gonna match up the parts, right? And make sure that, first of all, let's make sure first that we have the correct parts to show the triangles are congruent. Second of all, let's make sure it's matched up correctly. Well, you have some choices here. You have some choices on number 1 here. You could use side angle side. Notice we have two sides and the angle between. All right, so we could use side angle side. My picture there was a little off the screen. Let me, oops, sorry. We don't want that. I unfortunately don't have great orientation. There we go. Sorry about that. So notice we have side angle side here. And if you don't like side angle side, well, using the reflexive property, this is congruent to itself. So look at that. We have two ways to prove the triangle is congruent. So long as this is named correctly, this is a true statement. Right, so let's see. GH goes with GJ. GH goes with GJ. Well, we have two ways to show the triangle is congruent. Unfortunately, look at the way it's labeled. GH and GJ. Are those two sides congruent? Well, they are not. All right, so our corresponding parts aren't matched. So is the congruent statement true? This is false. Although the triangles themselves are congruent, our statement is incorrect. We'd have to change it. So false, the corresponding parts are not matched. So you got to watch. And even though your triangles may be congruent, if you don't match the corresponding parts are not matched, then your statement is false. So let's make that a true statement. Right? It would be a true statement if we said that, actually I'm going to need a little bit more space here. Let's get rid of all these markings. We're just going to leave up that part there, showing that the sides are, we have three pairs of sides congruent as well. If we said, let's just keep GHI. So triangle GHI is congruent to GH. It's going to go with IJ, right? Because H and J are congruent. So IJ, my shadow keeps blocking, IJG. Oops, and the little triangle symbol there. Well, now you can't see the I. Triangle IJG, right? IJG. Yep, that one's correct now. All right, so it was false the way it's marked, but now we've corrected it. Let's take a look at the other one. Here you also have different ways to prove the triangle is congruent. Probably the easiest is just using side, side, side. Side, 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 side. There we go, three sides. Because using the reflexive property, the shared side is also congruent. We do have, I don't know if you noticed these up here, we have parallel lines, right? Well, parallel lines means we have some congruent angles. The angles that we have congruent are these two, right? This is a transversal right here. And those angles right there are alternate interior angles. So we have RT is congruent to itself. RT is congruent to TR using the reflexive property. And we also have angle SRT. I'll have to put it over here. Angle SRT congruent to angle UTR because they are alternate interior angles. Oops, my S is off the screen. Alternate interior angles formed by parallel lines. All right, so you have your choice here. You can either use side, 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 or side, angle, side. Now, if you're using side, angle, side, you may think, hey, that's not the included angle. It's not U and S. But we also have RT congruent to TR. All right, so that angle there is between sides. So angle SRT is between sides RT, which is congruent using the reflexive property, and RS, which was given. And angle UTR is between TR, using the reflexive property, and UT, which was given. So we do have side, angle, side, or side, side, side. So as long as this is named, if this is named correctly, we're good. So RST goes with TUR. Yes, this is correct. So this is a true statement using side, 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 angle, side. But you need to include this. So if I leave that out and I just say true, side, 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 or side, angle, side, right, I haven't explained it well enough. Right? I haven't justified. Right? You have to convince me that that's a true statement. Right? The convincing is that we have our if we're going to use side angle side, we need to state that RT is congruent to TR using the reflexive property, and angle SRT is congruent to angle UTR because those are alternate interior angles formed by parallel lines. We need to include the parallel lines, especially because I didn't even say that RS is parallel to TU. I have it marked there, but if this is a proof, I'd want to say that as well. So I at least need to include the parallel lines part somewhere. And then I can use side angle side. If I want to use side, 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 I need to include, so I need this one for side angles, for side, 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 right? And I need this one and this one for side angle side, right? I need to show there are 3 pairs of corresponding sides or 2 pairs of corresponding sides and the angles between. I think there's one more slide on this podcast and then a very short second podcast. All right, so actually I think maybe there's 2 more slides, but this one is pretty short and the next one's even shorter. All right, so here we're going to add a postulate that we've talked about, but we haven't really used, at least in a triangle congruence postulate, that a triangle congruence proof. That is that a midpoint divides a line segment into 2 congruent parts. So if we're told that H is the midpoint of GK, then we also know that GH is congruent to HJ because a midpoint divides a line segment into 2 equal parts. Right? So if H is the midpoint of GK, then GH is congruent to KH because a midpoint divides a line segment into 2 congruent parts. Right? That's the definition of, what happened to my S? I got 2 congruent part. That's the definition of midpoint. All right? So here we have our little proof. So we have GF congruent to KT. That one was a given. And so is FH congruent to TH. Those 2 were given there. How does my... We've got J's up there, and we've got T's down here. That's called El typo. So let's make all the T's be J's. Actually, maybe it's easier to make the one. Yeah, we'll just make them. I already started. All right, so you be a J. There we go. Now it all matches up. Those should be J's. All right, so these 2 here are given. They are in the diagram. They are a picture clue. All right, that's a picture given, and that's fine. And HG is congruent to HK, and this is by the definition of midpoint, or midpoint divides a line segment into 2 congruent parts. Both are fine. I'm actually going to write, I'll put a little star right here because I wrote it right here. Right? That's going to be our reasoning there. And so now we have 3 pairs of corresponding sides that are congruent. Right? So therefore we know that our triangle FGH is congruent to triangle JKH. So now we're going to bring in a few more definitions and things we know about features of segments and angles to help prove triangles congruent. So here we have midpoint. Okay? Something to add to our list of reasonings for proving parts of triangles congruent. Man, my mouth does not want to work today. I am all tongue-tied. All right, the congruent statement is triangle ABC congruent to HJK. Is that true or false? You need to be very careful that you get the corresponding parts in the correct order. So for instance, if I say CAB, right, notice the direction I went. Right, and that's not a parallel line marking. I'm just trying to show you I went that direction. Is not congruent to H. Actually, you know what? Here, I'll use different colors so you can, oops, so you can see the colors. I don't know what I did to make my slide move, but I don't like it. There we go. I got slides moving. I got tongue-tiedness. All right, so CA, HK, AB, KJ, and the last one, of course, would be the one that's left over. All right, so now if we look at those, well, you can see that the lines, the colors there, don't match the congruent symbols. Right? AB and KJ, they're not congruent. They have different number of hash marks on them. So there, in the statement below, I've mixed up my corresponding parts. I didn't match them up. Right? So this statement here, that's false. Right? CAB congruent to HKJ, false. Right? That's not congruent. However, AB and HJ, that looks good. And BC and KJ, so I'm just reading across my statement there. And JK, well, that looks good. And then CA and KH, well, that looks good. So that was true. That's a true statement. Right, and that's going to end this podcast. I'll be back in the next podcast, and it's a fairly short podcast. I think I've only got about 3 or 4 slides. All right, bye.